Hello, my beautiful calculus period 8 folks. I'm really sorry I can't be there today. However, we are learning 2 theorems today that are going to feel very familiar because they're kind of a combination between what we did last class and all year long. So Rolle's and mean value theorem are 2 new theorems. You have to check some conditions before you can apply them. So let's check the first 2. This is going to be for the mean value theorem. Given the following graphs, determine if they are continuous and differentiable. So I'm going to do the first one with you, and then I'll have you see if you can figure out the other 2. So our first one, it is continuous, right? There's no gaps, holes, or asymptotes. However, what is wrong with that guy? That's right. He's not differentiable. You can't take the derivative of a corner. So try B and C for me. Pause the video, and when you're back, I'll have the answers. All right, folks, so our first one was not differentiable, but it was continuous. B is continuous and differentiable, so we can actually apply the mean value theorem. And then letter C is not continuous, nor is it differentiable because of this gosh darn asymptote. All right, so mean value theorem, you have to check those conditions first. Then we'll talk about what visually this looks like in a second. So if your function is continuous on the closed interval, just be careful, closed interval, differentiable on an open interval. So what's weird is you can have an asymptote at the end of a function and this still works. So I could have like a graph that looks like this, but it is differentiable as long as I'm only going from like 0 to whatever this is. That's okay. Then it's saying there is a point where the derivative equals the slope between the endpoints. So visually, what that looks like is this. Not what it looks like. That's weird. You guys have it on the bottom of your page. Sorry. Okay. So in other words, they're saying that for the mean value theorem, as long as you're continuous and differentiable, the slope between your 2 endpoints, they're saying there's a point on that graph that gives you the exact same slope. So same thing here. If I graphed the slope between my 2 endpoints, boop, 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 boop. This one actually has 2 that have that same slope, right? Can you envision that, hopefully? Okay. So first of all, we want to check if this is continuous and differentiable first. Sorry, I can't actually pull these out, but think about a polynomial, right? A polynomial is always going to be differentiable. You can just do diff, check, and it's continuous, check. So then we're allowed to do this thing, all right? This means that the slope between the 2 points, which is the right-hand side, also has the slope somewhere else in the function. That means I would have to take the derivative. Let's actually find the slope between the 2 points first, the 2 endpoints. So this is our A, this is our B. So if I find the slope between them, I'm going to do f of B. That means I have to do f of 2 minus f of 0 all over 2 minus 0. So literally that's the slope between the 2 points. F of 2 I get by plugging 2 in for that. Same thing with 0. So we know this one's going to be minus a negative 1. So just be careful of that. If you plug in 2, you end up with 9. And then this gives you 2. So your slope is 5. So what this is saying is that there is some C value, it's really an X value, just so you know. There's some C value that gives you that same slope of 5. Okay, so I'm going to take my derivative and I'm going to set it equal to 5. Just be careful, that's a little different than when we were finding critical numbers. My derivative would be 3x squared plus 1. I have to set that equal to 5. So then subtract 1. 3x squared equals 4. Divide by 3. Square root both sides. Ba, ba, ba. So you end up with plus or minus 2, because that's the square root of 4, over radical 3. And you guys don't need to rationalize it. But there's a problem, which you may notice. One of them doesn't work. Bum, bum, bum. Check your interval. Make sure it fits. So the only one that we get is positive 2/3. So how we write our final answer is going to say the derivative at 2 over radical 3 equals 5, because that is the slope that matches the slope between our endpoints. Boom. All right, next one. And by next one, I mean that is, move to the next slide. Okay, cool. So this one, what I want you to do first is talk to somebody near you. You can pause the video. See if you can figure out why we cannot apply the mean value theorem here. No MVT. Tell me why though. Pause the video, chat it out. All right, so no MVT because think about the graph of this, right? It's probably closed and it's all that good, but the problem is that you have 2 vertical asymptotes here. Think about what that means. So that is not continuous, okay? So you can't even do it, which is kind of nice when that happens because then you don't have to solve the problem. Sweet. All right. One thing I want to point out in this question is that we do have a vertical asymptote at x equals 0, which is actually okay because it's not in our interval. Remember, you also want to check for, has to be continuous between the closed interval, but it has to be differentiable on the open interval. So as long as you have this outside of that interval, you're good. So we actually can apply MVT. So you want to say it's continuous within the interval and it is differentiable. We're allowed to keep going. So continuous differentiable, you want to say that first because otherwise there's no point. But let's find our slope between the points first. So f of 4 minus f of 1 over 4 minus 1. Take a sec and find that for me. I'm going to pause. Tell me what you get. All right, hopefully you got 1. So that means that that's the slope between my endpoints. And now I want to see what the x value is, or we call it c. That gives me the same slope on the function, which means I need to find my derivative. So remember, my derivative should have the same value at that point. So I'm going to say this is the derivative of 5 is 0, right? You can rewrite this part. Really, you can rewrite it as 5 minus 4x to the negative 1, and then it's easier to take the derivative, so you don't have to use quotient. So if I take the derivative of that, the derivative of 5 is 0, so this would be 4x to the negative 2, and then I have to set that equal to 1. So just be careful, we're not finding critical values, we're finding out where the derivative is equal to 1, aka it has the same slope as the endpoints. So to solve this, that's the same thing as 4 over x squared equals 1. You can cross multiply. And then you get x equals plus or minus 2. However, dun dun dun, one doesn't work. Which one? Think about it. That's right, negative 2 doesn't work. So we get x equals 2, which means our final answer would be written like this. F prime of 2, because that's the c value where that happens, equals 1, because that was the slope between my endpoints. Okie dokie. If this is confusing at all, folks, you can ask me next class for clarifying questions. The last theorem is called Rolle's theorem. So notice it has the same restrictions as MVT, or mean value theorem, except it requires your endpoints to match. So visually, it's saying that there is some point between the two endpoints that actually has a derivative of 0. So it's saying there's a critical number. So it's really saying that there's a max or a min, right? So as long as it's saying those endpoints exist, we're allowed to move on and say, because they match, there's a point in between them that's a max or min, basically. All right, think about that being a critical value. So these are some cases where that would work. So continuous, it's differentiable. The endpoints have the same height. Same thing here. They're saying there's a derivative of 0 somewhere. This one's a little odd because our derivative is still 0, but it's like a line instead. This one has 2, because we have a max and a min. All right, so let's see this in practice a little bit. And then we're almost done. Yay! you guys can work on homework because you're probably gonna finish this before the end of class. All right, so why do these not meet roles? I actually would like for you to figure out why these don't meet roles. There's a few reasons actually for some of them, but none of them actually meet roles for a reason. So just write down what you think first. All right, so hopefully you were able to figure out why these are not gonna work. There's many reasons why this first one doesn't work, but it's because it's not continuous, right? There's actually asymptotes going on here. What's wrong with this guy? Not differentiable. Or lady, if you think about derivatives as ladies. Differentiable. This one, we could totally use MVT for this. However, we cannot use Rolle's because the endpoints, no matchy. Okay, so because they don't match, does not work. One thing to point out about absolute value functions, you guys actually can't find the derivative of them. So because this is an absolute value, hopefully some of us remember our vertex would be here at -5, 0. So because the vertex is in this interval, we cannot use Rolle's because we can't take the derivative of an absolute value function. So because my graph looks like that, and if I'm only going between -10 and 0, it's really just like this part, my derivative doesn't exist there. So I actually can't use Rolle's because it's not differentiable. The difference is if I were to graph this one, I'm only graphing it between -2 and 0, so this function is actually going to look more like a line. So I actually could use MVT. The reason I can't use Rolle's here is because if I plug in -2 and 0, they actually don't match because I get 3 and I get 5. So no matchy. Can't do it. Okay, so you can't use Rolle's because of that. So this one I actually could use MVT because I could just find the derivative, aka the slope of that little segment. But check where the vertex is normally because you want to make sure it fits in the interval or not. All right, so think of your three conditions for this question. I'll have you do the last one on your own, but this one we want to make sure that it is continuous, which cosine is continuous. Can we find the derivative of cosine? Yes. It's a differentiable. So continuous differentiable. Last thing we want to do is find our endpoints and see if they match. So I have to do f of -π/12. And then I have to do f of π/6 and see if my y values match. So you guys actually can do this without a calculator because if I do cosine of -π/12, but I have a 2 there, it's cosine of 2 times -π/12, which is really cosine of -π/6, which is radical 3/2. And then same thing here, this turns into cosine of π/3 because the 2 cancels. That is not the same thing. So because no matchy, you don't have to write that if you don't want to. You just say they don't match. So Rolle's can't be applied because they don't match. All right. The next one and final one, I just want you to, actually it's not the final, I lied. I just want you to find the next one to see if you can apply Rolle's theorem, please. So pause the video, there are a few more, but some of them you don't need to apply Rolle's for, so there'll be less work. So just check your 3 conditions first to see if you can apply it, and then we'll solve it together. All right, folks, does it work? So it is continuous because it's a polynomial. We can differentiate because it's a polynomial. And the endpoints do match. So just be careful because Rolle's theorem says that means that there is a coordinate on your graph that has a slope of 0, meaning it's probably a max or min, but we don't really care that much about that part. So you have to find your derivative. This time you're setting it equal to 0. So we're really finding it if it's a critical number. So you get -12 plus 6x, solve that for 0. You end up with x equals 2. Is it in the interval? Yes, it is. So we can say f prime of 2 equals 0. Be careful, it's 0, not a random number. All right, I want you to find the bottom two. You're probably going to need a graphing calculator for the last one. Just make sure you're in radian mode. But check the conditions first, see if they're met. If not, then you don't have to solve for the things. And if they are met, then you got to solve for the stuff and the things. Feel free to look back at your notes to check what those things are. When you're done, unpause the video and I'll have all of the answers for you. All right, folks, hopefully you found out for the first one there that you cannot apply rules because the vertex for this absolute value function is at 3, 3. You really just need the x value, just so you know on that, but it is the opposite sign, so it's 3. Hopefully you remember that from Algebra 2. But because that's in that interval, that means it's not differentiable at that vertex, so I can't apply rules. The next one, I said you can use your graphing calculator to graph it to see if it is continuous and differentiable. So just so you know, we can always take the derivative of sine and cosine functions, but it is continuous. It is, yes, continuous. So just check that off. 2, you can say it is differentiable. It should look something like a straight horizontal line when you graph it, which is weird, but that's because they have pi over 6 in there. And then you want to check your endpoints. So you want to do f of -1 and f of 0, and you can do that straight up in your calculator. But you do end up with 0 for both. So they do match. Matchy. Okay. You can technically solve this by hand, but you're welcome to, because they said use a graphing calculator, plug the function into y1. And then, or sorry, the derivative into y1, and then you would solve for where it crosses the x-axis, because that's your zeros, right? You're trying to figure out where f prime of x equals 0. So let's find my derivative by hand first, just to verify that. So that would be 1/2 minus cosine of pi x over 6. Remember, you have to do times the derivative of the inside, so that means it would be times pi over 6. So my derivative is 1/2 minus, I would write that as pi over 6 cosine of x times pi over 6, but you can leave it like that for now if you want to. So really you're setting that equal to 0. So if you're curious as to how to solve that by hand, you are going to need a graphing calculator regardless, but you also can now plug this whole function into y1 and plug in 0 for y2 and find the intersection, or you can find the zeros in your graphing calculator. Either way, to solve it by hand, in case you're curious, subtract the 1/2 to both sides. So it'd be -1/2 equals, I'm going to throw the pi over 6 here in front. So I'd multiply both sides by 6 over pi to undo that fraction. So I end up with 6 over 2 pi equals cosine of pi over 6x. So then that's really 3 pi equals, oh, it's divided by pi, I lied. So it's 3 over pi equals cosine of pi over 6x. So 3 over pi is not a number that we can find on our unit circle, so you would actually want to do inverse cosine. And sorry, this pi should have been underneath the fraction, just so you know. So it is 3 over pi because you're doing 6 over 2 pi. But you could do inverse cosine in your calc of 3 over pi, get an answer, and multiply that answer by 6 over pi. Now, just so you know, when you do that in your calculator, you end up with -0.58, which is in that interval they gave you, so that works. So you don't actually need to find two answers like we used to in pre-calc. So you would say f prime of -0.58 equals 0, and that is your answer. So folks, if you finished early, grab a textbook, you can start your homework. And please let me know if you have questions. You can email me or let me know next class. Have a great day. Bye.